Hello again, Psych 370 students, and welcome to one last video lecture for week 15. In this one, I'm going to be talking about some of the variables that affect observational learning. Now, you can also read about these, if you haven't already, on pages 292 through 299 of the textbook, but I do want to provide at least a basic overview here of how tweaking certain variables might affect the learning that occurs through observation. First of all, it probably won't surprise you that one important category of those variables has to do with the characteristics of the person who models the observed behavior. So, for example, research indicates that models who are very attractive, very likable, or very high in status are especially likely to be imitated. And of course, that's one reason why celebrity endorsements are so common, right? I mean, celebrities tend to be attractive, likable, prestigious individuals. So if they claim to use a particular product, then consumers are likely to follow their lead and use the product themselves. So, characteristics of the model can affect the process of observational learning. And your book describes several studies which seem to indicate that. But it's also clear from research on the imitation of the violent, aggressive behavior that's often depicted in the media. That's obviously a big area of research and observational learning, right? Do children in particular, acquire more aggressive tendencies as a result of observing media violence? And the evidence suggests that they do, especially when the violence being depicted is being carried out by characters who are physically attractive, who are portrayed as the good guys, and also when the viewers perceive the perpetrators of that violence as being similar to themselves in some important way. So, in addition to attractiveness, likability, and status, similarity to the model is another important variable in observational learning. The more a viewer identifies with the model, the more they can sort of see themselves in that model, the more likely they are to learn from that model. And as I've explained on the slide here, one reason this may be is because we're more likely to pay attention to and remember models who are attractive, who are prestigious, whom we perceive as similar to ourselves, and so on. But the more general point is that when it comes to observational learning, it does matter who the model is. Characteristics of the model do affect the learning that occurs from observing that model. Now, of course, one particular characteristic of the model that some researchers have considered is the model's skill level. So sometimes when we learn from a model, we watch as the model puts on a skilled performance, right? For example, if you take a tennis lesson or a piano lesson, you're going to have a skilled model. Your teacher is going to know how to play tennis or the piano. So they're going to be able to demonstrate the proper technique for you right from the beginning of the lesson. However, other times, the model that you're learning from might be unskilled. And guys, models like that, unskilled models like that, are also known in research on this as learning models. Okay. We also call them learning models because the observer watches as this unskilled model learns how to perform a particular task. So, for example, in the Herbert and Harsh study that I described in my first video lecture for this week with the cats and the turntable problem, those observer cats watched an unskilled learning model, right? So the observers got to see the model's first attempt to solve the turntable problem. They got to see all of the model's successes and all of its failures as it learned to perform that task. And then the observers tried to solve the problem themselves. So that's a pretty important characteristic of the model to think about here. Is that model skilled or unskilled? And it might seem like watching a skilled model would be a better, more effective way to learn through observation. But then, on the other hand, there's also a case to be made for watching an unskilled model. Because after all, when you watch an inexperienced person learn how to do something, when you watch that unskilled model go through the process of becoming more skilled, then you get the chance to learn not only from what that model does right, but also from what it does wrong. And so it could be that learning models are more effective, right? It could be that we learn better when we get to see the errors that a person makes and the improvement that they make as they learn to do something. So it's not obvious either way whether skilled models or unskilled models would lead to better observational learning. And as your book points out, the research on this skill of the model variable has yielded mixed results. Some studies find better learning from skilled models, others find the opposite. And so, this is another ongoing area of research and observational learning. And it's possible that the reason we're seeing mixed results in the research is because the skill of the model interacts with other variables, like how much observation is being done. For example, it could be that if you only get to observe a model a few times, if there's a limit to how much observation you can do, then you may be better off observing a skilled model. But if you have the chance to make a larger set of observations, then that might be when it's more beneficial to watch the trials and tribulations that an unskilled model would go through. But anyway, again, characteristics of the model are one sort of category of variables that have gotten some attention in research on observational learning. But characteristics of the observers themselves also matter. For example, one important characteristic the researchers have identified is the age of the observer. Now, I mentioned in a previous video lecture that adults are more likely to over imitate than children are, and that's true. But in that research, the adults and the children were specifically instructed to watch a demonstration in order to learn how to solve a problem, right? They were told to imitate, in other words. Now, they weren't told to over imitate. In fact, they were explicitly instructed to try not to over imitate because the researchers would tell them not to do anything silly or unnecessary. So that's not why the adults showed more over imitation than the kids did. But it was obviously implied in that research that the way to figure out how to solve these problems was to watch a model do it first. And so everyone did that, both the young people and the older people. However, when it's up to the observers themselves to decide whether or not to watch a model and imitate that model's behavior, then research indicates that younger participants are more likely to do that than older ones are. Now, older people do tend to learn more and faster from observing a model when they actually do so. But as you might expect, younger subjects tend to be more likely to choose to observe and imitate that model in the first place. So, in other words, whereas kids will readily watch and learn from other people, adults seem to be less inclined to do that, even though, at least until very late adulthood, we actually learn quite well when we do. So, age matters. Sex also seems to matter, at least in chimps. So, for example, some research has found that female chimpanzees will learn through observation more quickly than males will, possibly because females tend to observe other chimps more often and at younger ages than males do. And certain disorders, like autism, are also associated with deficits in observational learning. So, for a variety of reasons, kids with autism spectrum disorder don't seem to learn as well as their peers do from observing events and their consequences. And neither do kids who have the sorts of intellectual disabilities that would have in the past been called mental retardation. And so, the developmental age of the observer, or the typicality of the observer's development, is another important variable here that influences observational learning. So, it matters who the model is. It matters who the observer is. And obviously, it also matters how difficult the task being learned is. In general, the harder that task is, the less likely it is that you're going to be able to learn how to do it just by watching someone else do it. So, easy tasks can be learned through observation much more readily than difficult tasks can. And that's pretty intuitive. But an interesting finding here in the research on task difficulty is that models may be especially helpful for learning more difficult tasks through observation, and they may be less helpful for learning less difficult tasks. For example, in a study that I also mentioned in a previous video lecture, 1 to 2 year old children were presented with problems where a toy would be placed on a mat and the kids would have to figure out how to retrieve the toy. And basically, there were two versions of the task. One was easy because there was just one mat that the kids had to push. The other one was harder because there were two mats and the kids actually had to push the one that didn't have the toy on it. And as you can see in the graph, with the easy task, the kids actually learned better in the ghost condition, where they saw the mat appear to move all by itself. But with the harder task, the kids learned best when there was a model there who demonstrated how to get the toy. And so it seems like there might be an interaction here between task difficulty and the presence versus the absence of the model, with social observational learning being better for more difficult tasks and asocial observational learning possibly being better for easier tasks. Okay, so I've talked a little bit in this video lecture about characteristics of the model, characteristics of the observer, the difficulty of the task. And next, another fairly intuitive factor that affects observational learning involves the consequences that the model experiences. So, what happens to the model after they do the thing that you observe them doing? That matters too, right? Obviously, if the model does something and then they experience a good consequence afterward, then you're going to be likely to perform that behavior too. That behavior is going to get vicariously reinforced in you. And if the model does something and then experiences a bad consequence afterward, then you're probably not going to perform that same behavior. You probably won't imitate it because that behavior is going to get vicariously punished for you. And so it certainly seems like the consequences of the model's behavior, the consequences of the observed act, should matter. And they do. This has been clearly demonstrated in research. For example, your book describes a study where kids were more likely to play aggressively with a toy if they saw a model being aggressive with it and then being praised for that behavior. The kids were much less likely to imitate the aggressive play if they saw aggressive play being criticized. So, the consequences that we see the model experiencing will obviously affect whether or not we imitate that behavior. They'll obviously affect whether and what we learn from that model. But one last thing that I want to mention here is that we also need to consider the consequences of the observer's own behavior. So, the model's consequences probably matter because we assume that our behavior will produce the same consequences as the models did. But if we actually put that assumption to the test and imitate the behavior that we saw, then it obviously matters whether that imitated behavior gets followed by a reinforcer or a punisher or no consequence at all. So this kind of goes back to what I said in a previous video lecture about generalized imitation, right? If imitating someone else's behavior gets reinforced, then that imitation will tend to continue. But if it doesn't, then it won't. Now, there's a classic study, which is briefly summarized in your textbook, that illustrated this basic point about imitation continuing when it's reinforced and not when it isn't. So I'm going to finish up here by describing that study for you. It was conducted back in the 40s by Neil Miller and John Dollard. And the participants in this study were first grade children who participated in pairs. In each pair, one child was designated as the leader, the other was designated as the learner, and each trial in the experiment involved having the kids turn the handle of a machine in a particular direction. If they turned it in the correct direction, then they got some candy, so the candy was the reinforcer. But if they turned it in the wrong direction, then they didn't get candy. Now, in each pair, the leader always went first. That's what made them the leader. And that leader was told in advance to turn the handle in a particular direction. So the researchers told the leaders which direction to turn the handle in. The learner could see which direction the leader turned the handle in, but they couldn't see whether or not the leader got any candy for turning it in that direction. So in this study, the leaders were basically the models, right? They were modeling a behavior for the learners. So the learners were the observers. The consequences of the leader's behavior was unknown to the learners. So the experimenters controlled for that variable. And it was the learner's behavior that the researchers were most interested in. Now, half of the learners were in an imitation group, meaning that they got reinforced with candy if they turned the handle in the same direction that the leader had turned it in. And the other half of the learners were in a non imitation group, meaning that they got reinforced with candy if they turned the handle in the direction opposite of the one that the leader had turned it in. And so you can probably guess how the results of the study turned out. Before long, the learners in the imitation group were always turning the handle in the same direction that the leaders had used. And the learners in the non imitation group were always turning the handle in the direction opposite of the one that the leaders had used. And so, again, the point here is that imitation is not likely to continue if it isn't being reinforced. So, in this study, children imitated the leaders if doing so produced candy as a result, but other children learned not to imitate the leaders if imitation didn't result in candy. So, guys, observational learning is very common and very beneficial. But the point is, ultimately, it's the consequences of the observer's own behavior that determine whether they're going to keep doing something they've seen a model do. In other words, we can acquire changes in our behavior through observation. But once we have, it's up to our old friend operant conditioning to reinforce those changes, to punish them, or to extinguish them. Okay, well, that's going to do it for the video lectures for this week. As always, please let me know if you have any questions about this stuff, and I'll catch you again next week when we finish our coverage of observational learning. Take care.